Thanks for taking the time in any case. These two presentations today are going to be somewhat, there's going to be a little bit of a connection in between the two. But I'll start with the Spring part of the evening. This particular presentation is very much a Spring Framework 5.x presentation, like 5.1, 5.2 presentation. So let me start with just asking, who is familiar with Spring? Let me reduce it to actively working with Spring, like building Spring-based applications. Okay, that's a decent number indeed. Inverse question, who is not familiar with Spring at all? It's okay to raise your hand, there's no need to be shy. All right, but that's perfect because that means we can go right into the presentation really. While I have you, right, who's on Spring Framework 5? Okay, so I suppose quite a few hands. Who's on Framework 4.3 or 4.x? All right, the Spring Framework versioning scheme that we're talking about here, of course, is the well-established core framework versioning, and my own background is to be the project lead and the release manager of the core framework. So let me lead right into the topics. This is a selection of 3 areas that we're going to focus on, very much core framework areas. So we're not going to talk about Spring Data or Spring Boot. We might refer to them once or twice, but the topic of this particular presentation is really the core framework itself. And keep in mind that by core framework we mean everything under the Spring-Framework umbrella on GitHub. That's actually quite a lot. There's the core container, the core JDBC support, the core JPA support, the entire web foundation, web MVC, web flux, all of this, the core messaging module, all of this is part of what we call the core framework, right? The Spring Framework itself. So just to set that straight. Core container revisited. We are revisiting the core container every now and then. Major versions of Spring itself, of the Spring Framework itself, are always an opportunity to us. It usually comes with a baseline upgrade. So you might remember in Spring Framework 4.0, for example, we had a huge theme, Java 8 support, JDK 8 support, but at that time optional JDK 8 support. For Spring Framework 5, or Spring Framework 5.0, we were finally able to raise the baseline to JDK 8 plus. This is always an opportunity. Like with every code base, the moment we can start using new Java language constructs and API constructs across the code base, that's of course always a fine point to arrive at, and we're always making good use of that opportunity. And that's going to be our first, or at least the lead into our first topic. In Spring Framework 5.0, we started an API revision. It's mostly an API revision. I'm mostly talking about an API revision because that's what you're interacting with. The interfaces, the annotations, other API types in the core framework, of course. But there's a lot of background work as well. We literally went through the entire implementation, every single source file, essentially. Updating it to Java 8 language conventions, and this is an ongoing effort. It's continuing. We did a lot in 5.0. We had a lot of contributions afterwards, mostly, that kept fine-tuning the use of Java 8 language constructs. So we did a lot of it in 5.1, and it's continuing in 5.2. I see it as a bit of a completion of the effort in 5.2, but you never know when you're done in software. So anyway, the opportunity, as mentioned, is this Java 8 baseline. The baseline means we can require the availability of Java 8 API. That's actually quite huge in its own right. Java 8 is not only new language constructs like Lambda expressions and method references that you were able to use against Spring APIs already, just against Spring Framework 4, just by compiling your code with Java 8 and binding it to API constructs that we were shipping that were Java 8 compatible, but not actually Java 8 based. as of Spring Framework 5, everything is Java 8 based. And we're making use of some Java 8 features that we were not able to use before. For example, some common Java 8 API types, the Java util function package, supplier, consumer, predicates, collection streams, the Java util stream type, and it's all of the little world that comes with it. Completable future, the Java time types, instant, duration, local date time. To use those types, to have hard references to those types in APIs of ours at the core framework level really means that we're requiring Java 8. We're bringing in Java 8 for every user. And so as of Spring Framework 5, we're able to do this. It's mostly overloaded methods where you were able to pass in, say, a long of milliseconds or a Java util date before. In all likelihood, in such places across the framework, there are now overloaded methods taking the appropriate java.time type, right? Mostly instant, in some cases it's local datetime, zone datetime, or duration. So this is an effort that really brings a lot of convenience when you're using Java time types yourself in your code, and it's just nice and a little more modern, of course, in general. The other huge area that we were only able to address recently in Spring Framework 5 is the use of default methods. You might be aware that in Java 8 that there's this concept of a default method in an interface. It's basically a method in an interface with a default implementation, within a default implementation within the interface. There's some quite nice benefits coming with this. You may implement all but one method in an interface as default methods, leaving one method that is serving as the target method for a functional interface. So you can use that interface for a Lambda expression or a method reference in Java 8, despite further methods being defined on that interface. So there's quite a few benefits. Those are tools for us as framework designers, as framework API designers, and we're making good use of it. Many existing interfaces have been revisited. So many of the common API types, in particular the callback interfaces, the bean post-processor interfaces, transaction synchronization. There are quite a few interfaces with several methods. Most of them are now coming with empty default methods. So if you choose to implement them, if you need to implement them, you only implement the method that you're interested in with the interface directly. No adapter types necessary anymore. And for evolving the framework, that's actually the main feature of Java 8 default methods. For evolving the framework, when we introduce new methods to existing interfaces, we can now declare them as default methods, which means that existing implementers are not broken. They don't need to implement that new method. It comes with the default implementation in the interface. This is in particular important for binary compatibility with third-party extensions. And there are many, many third-party extensions with very close interaction with core Spring APIs out there. All the Spring support in the likes of ThymeLeaf, Jersey, MyBetis, all of those ship Spring support on their end. And of course, if you get their jars from Maven Central, they are pre-compiled, so we need to spend the extra effort to keep them compatible even across major core framework releases of ours. This was a Java 8 motivated exercise by having Java 8 as a foundation. There's a sort of complementary effort of ours that has not much to do with Java 8 at all, but goes very nicely with the API design conventions that we have these days and the API design conventions that Java 8 brought onto the table. It's about nullability. It's about being explicit about nullable or non-nullable arguments. So it's about constructor arguments, method return values, most importantly. We explicitly declare whether any such argument or return value is actually nullable. To be more specific, we have a non-null by default convention that we're declaring on our packages. So for any tools that are able to validate those assumptions and those declarations, there's a non-null by default convention. So without any further declaration in the source code or in the Java doc, there's a non-null assumption, so the argument has to be non-null and the return value will always be non-null. If a return value can be null, you'll find an at-nullable annotation on the method. If a particular argument, a constructor parameter, method parameter can be null, you'll find an at-nullable annotation on that particular parameter in the signature, which is of course showing when you look at our source code, it's showing when you look at our documentation, and it's a formal declaration. We're not talking about Javadoc text, right, where we used to say this can be null, this can never be null, may be null, whatever. This may so quickly become out of date and it may not be very telling. This is a formal declaration that can be validated by tools, and that's exactly what we're doing ourselves. We're using in particular IntelliJ IDEA and its nullability support. There are several inspections in IntelliJ, like the constant conditions, exceptions is the most interesting one, because it doesn't just validate the signatures. It looks at the entire flow of the code and double checks the assumptions that you're making in your code. So if you're saying this can never be null, does the code actually properly handle this? If this can be null, does it properly handle it? And it goes both ways. If something can be null and you're not checking it for null, you might run into a null pointer exception. But the less obvious part is the other way around. If something can never be null, there's no need to have if checks. And that was actually some of the surprise that we got when we went through that exercise. We could remove quite a bit of defensive code, unnecessary defensive assumptions, defensive checks for stuff that could never be null anyway at that point of execution. So tooling support is really great there for us. We also fine-tuned some nullability. If you're upgrading from earlier Spring Framework versions to Spring Framework 5, you potentially might find places that used to accept null or return null that don't accept null or return null anymore. Formally declaring in Spring Framework 5, you can just double check your assumption by looking at the signatures, whereas in Spring Framework 4 we basically just had weak assumptions. We fine-tuned them in a few places where it makes sense from a usability perspective. Another important effect is with the Kotlin language, with the Kotlin compiler. In Java, basically, there is no nullability in the language, no formal non-null declaration in the language. We just use annotations and some tools to help us out. In Kotlin, there is nullability in the type system. You may declare a non-null reference, and the Kotlin compiler only allows you to assign the outcome, for example, of a method call to such a non-null declaration if it knows that this can actually never be null. So the Kotlin compiler requires some formal declaration in the target APIs that say this will never be null. And this is actually one of the key motivations why we're doing this. It's for idiomatic use of Kotlin. The Kotlin compiler understands our nullability annotations and can make a safe assumption, a strict assumption about a return value never being null. If we declare it non-null by default and there is no at-nullable annotation on it, the Kotlin compiler can make that assumption. There's a bit of a story around tooling integration. We have JSR 305 meta annotations so that Eclipse and other tools can understand those same annotations. But by far, the biggest and most consistent value comes out of the use of IntelliJ IDEA. So if you're using IntelliJ IDEA, then your Java code can also be validated against the Spring Framework code that you're calling, because IntelliJ IDEA understands, of course, our annotations, and it would also understand those similar annotations in your code base and can then make control flow assumptions when you're calling our code, telling you whether you're overly defensive or whether you're potentially missing a null check somewhere. And of course, with Kotlin, it also comes out of JetBrains, right? The same company behind IntelliJ IDEA and Kotlin here. So it's no surprise that they're making good use of these features in Kotlin as well. Both as an example for what we do here, for what we did here, and as an example for some overloaded Java 8 constructs, let's look at ObjectProvider. You might not be aware of that particular type, but it's a fine example, and there are other types across the code base doing similar things. But ObjectProvider is essentially a sort of indirect handle on a target dependency. You can auto-wire an object provider of some target type, or you can call get bean provider of that target type as of 5.1 on a bean factory or an application context, giving you the same object provider of foo. This is not a resolved dependency reference yet. It is a handle that can resolve dependency instances for you once you need them, if you need them. So it's kind of lazy by default in terms of retrieving the reference, lazy in that sense, like an add lazy, add auto-wide reference, basically, another way to express that. But it's also a little more sophisticated in the questions that you can ask or in the instructions that you can give. Aside from just getting the object when you need it, as a sort of lazy reference, there's a getObject method for that. There are methods like getIfAvailable, give me the instance if there is one if there is any matching instance in the bean factory, and give me null if basically return null if there is no such instance. That is an old signature. It dates back to Spring Framework 4. We revised that signature in Spring Framework 5, so it's now getIfAvailable, same signature as before, but it explicitly says add nullable, because that's what its contract means, right? There might be an instance, or there might be null if there is no instance. The same for getIfUnique. That is also a Spring Framework 4.3 method, enforces an instance only to be returned if there's one and only one matching instance in the application context, and otherwise you get null. So both of them have to be annotated as add nullable, which means you can't assign them to a non-null declaration in Kotlin. You can't make safe non-null assumptions in your Java code either. It's at least explicit, right? Now, but in order to address the usability problem with such methods, we introduced a couple of overloads. And those use Java util function types. So getIfAvailable with a default supplier is kind of an easy way out. It basically says, if there's an instance in the application context, give it to me. Otherwise, let the default supplier produce a default or return a default instance and return that, right? You are the ones providing the default supplier, and Java util function interfaces can easily be bound to a Java 8 method reference or a Java 8 Lambda expression. So it's pretty convenient to use that signature, and you will never get null returned. So there's no add nullable here, non-null by default. Same for getIfUnique, but there's another twist here. To make things a little more functional, since in Spring Framework 5 we generally had a functional API design theme, functional as in Java 8, functional language features and functional API style. So we are also having a signature called ifAvailable with a consumer, which is a slightly different spin. You're basically saying, if an instance is available, matching that type in the application context, then call my consumer here, let me do something with that instance. Otherwise, skip that step. So there's no return value, it's void. And of course, you can supply a Lambda expression here. Just a Lambda expression that says, instance, arrow, do something with it, right? As you receive it. And the same for getIfUnique. So that's the sort of stuff we're doing. Java 8 language revisions using the Java util function packages for a more idiomatic, more functional, and more Java 8-oriented interaction style, and nullability declarations also illustrated above here. We're taking this a little bit further even in Spring Framework 5.1 already. So the same facility, as we just elaborated on, also has methods for retrieving several matching instances. So those are actually kind of brand new in 5.1 at least. So there's a good old iterator for the ones loving iterators or interacting with iterators, but the Java 8-oriented ones are those stream methods. Stream and ordered stream with slightly different semantics and slightly different implications in terms of lazy resolution. But that stream return type is the same Java util stream type that you would also get out of a collection. So you can interact with the Spring Core container, with a provider that the Spring Core container gives you. You can interact with it like you could with a Java util collection through the Stream API and its predicates and its find first, whatever you're using, right? So that's a quite nice wrap-up of that story that we are not only doing like functional callbacks, we're also doing stream interaction on some of our APIs. And this is a prime example, but there are several across the code base doing these things to existing APIs. Switching to the bean registration phase for a moment, you can of course use facilities like these in any kind of scenario. In the annotation-based component model, you can use it with class path scanned components, with explicitly registered components, with components coming out of configuration classes, at-bin methods in configuration classes. These facilities are totally decoupled from each other. You can mix and match them as you see fit. But this functional interaction style, this programmatic interaction style, has an equivalent in bean registration as well. So if for a moment, if we just forget about component scanning, if we forget about the annotation-based component model, forget about configuration classes, let's go down to the essence of it all. There's a Spring application context to be built. Generic application context is the typical starting point for that. There are, of course, this is an old class. There are tons of methods on there where you can register bean definition metadata. But there are a couple of sweet overloads now. These register bean methods are basically simple and functional style methods allowing you to register corresponding bean definitions for those component classes. If you just register a component class like foo.class, all you get is default conventions for it. Default conventions at the generic application context level are not that interesting. It's the default constructor to be called and not much else happening. But if you use a more specific setup, like an annotation config setup, if you activate annotation-based configuration, then it would actually use default conventions as per the annotation-based component model. So it would also detect that auto-wide constructors and so forth. More interestingly, there's the second variant here, the bar.class variant. This one is a little more explicit. It basically says, I'm going to tell you how to construct an instance of that bean once you need it. It's registering a bean definition for the component class bar.class, and then it passes in an instance supplier. This is signature-wise, again, a Java util function supplier bound to a Java 8 method reference here. It's basically saying whenever a new instance is needed, this little snippet is going to instantiate that class just through a new bar constructor. Bar has a reference to foo in the constructor, so it calls back to the container to obtain that instance of foo. Slightly more sophisticated down here, you can also fine-tune how that is supposed to happen. What if bar doesn't accept a foo instance in its constructor, but rather an object provider of foo? Then you can just pass in that object provider, calling back to the context to give you that object provider. If you want a singleton to be registered and you want it to be lazily initialized, so not on startup, but on first use, then you need what we call a bean definition customizer. This little extra line down here, the set lazy init one, is one more callback. It's again a Lambda expression bound to a bean definition customizer. There may be any number of those. So bean definition customizer is a functional interface passing the bean definition in, and you can add qualifiers, set the lazy init flag, add property values, whatever you want, right? So in this case, a typical example, setting it to lazy init, that's basically the equivalent of a configuration class with an add-bean method that produces one that produces a foo instance, one that produces a bar instance, and the bar one has an add lazy on the configuration method. So those features are directly equivalent to the ones that you can also trigger from the annotation-based component model, but there are no annotations here. There is no annotation processing in the background. There is not even reflection. Of course, there's no class path scanning because we didn't tell it to perform a class path scan. But there's not even reflection. Admittedly, in the version below, instantiating a class through the default constructor is technically reflection. In the version down here, we're not doing this. If you look at the foo line, We're actually saying register foo.class and use the given supplier, the given instance supplier, to construct the instance. And that instance supplier is a Java 8 method reference referring to the default constructor on foo. So foo::new is a Java 8 method reference to the default constructor. That's a little bit of a cheap way out of reflection because it's a direct dispatch to that constructor through an invoke dynamic instruction in the bytecode. So there technically is no reflection in that scenario down here. No reflection at all, not even for calling the default constructor. Not the main topic today, but there's a Kotlin equivalent that is also quite sweet, just giving you a visual impression of what that looks like. It's calling essentially the same facilities on the same generic application context, but it's not exactly calling the same methods. We ship Kotlin extensions. Kotlin extensions for quite a few classes across the code base. Kotlin extensions are essentially simple little additions to that class that are only visible to the Kotlin compiler. We ship them in our jars, so if you grab our jars from Maven Central, they will have the Kotlin extensions in there, but the Java compiler doesn't know what to do with them. It totally ignores them. And the Kotlin compiler detects them by convention, without any extra setup, and sees a few extra methods on some of our types. Generic application context, in particular, has a few extra overloaded methods. So again, further overloads. These ones take a Kotlin K class and a Kotlin K function, but you're not seeing this. What you're seeing is idiomatic Kotlin code where you're registering a bean of a particular Kotlin class type without having to say class.java if you know any Kotlin. No workarounds necessary, basically. This is idiomatic Kotlin style. The Kotlin function code says, well, register a bean, but it doesn't specify the component type. It just specifies a Kotlin function building an instance of that type. So that instance supplier thing that the core container dispatches to when it needs to create a new instance at the time that the core container chooses, right? So like before, the entire life cycle is up to the container, but there's a function creating those beans for us. No factory method, no add bean declaration, a Kotlin function in this case. And Kotlin functions come with a nice reflection API out of the box from Kotlin's side. So we can actually ask a Kotlin function, what type are you producing, right? What kind of instance, an instance of which type are you going to return? And the Kotlin function is going to tell us bar.class. So we know. And we don't need to ask you to tell us. So in contrast to the Java version, there is no bar.class, comma, and then the instance supplier here. There's just an instance supplier using Kotlin function facilities to find out what it produces. And the version below is just a bit of a use of Kotlin language variations against the same methods. So it's using a different syntax to specify the generics, and it uses nested calls. That's standard Kotlin features, nothing special that we do for this, but our extensions make it possible to also code it in this more DSL-oriented style. That I'm dubbing Gradle style usage because it has a, in style it's similar to the Kotlin DSL in the Gradle build tool. So as you can infer here, we're taking this pretty far. There's a lot of functionally oriented, essentially programmatic variants of doing things for sophisticated bean retrieval, for sophisticated programmatic bean registration. Remember, you can mix and match those features. There's no need to kind of go all in on annotations versus all in on functional. You can combine these things. You can instruct an application context to scan a certain package for annotated components and register some further beans with the facilities that we've just seen. So you can, of course, always use annotation-driven injection or programmatic injection, mixing and matching as you see fit across a code base. The only thing I would recommend is to have a strategy for it, right? Like a team-wide, a code base-wide arrangement where you agree on the code style that you're using or the code styles that you're using across a code base. We are essentially providing tools. Those tools are available to you as application development teams, as application architects, you may choose which of those tools you are going to use in a particular code base. Let's move on beyond the more stylistic and API-oriented questions to performance tuning. I'm specifically saying tuning here because we, again, are tool providers, sort of, right? Framework providers. We provide a lot of facilities for tuning performance, right? We don't automatically make things faster just so. We provide facilities and variations of our facility that allow you to optimize a particular application, a particular service, a particular code base for certain performance requirements. This can be startup performance, this can be peak performance. That's up to you to know what really matters in your scenario. This is a very hot topic in 5.2 in particular, but it actually started in 5.1. A particular topic of interest is annotation processing. So if we switch our mindset back to we have activated annotation-based configuration, we are using the annotation-based component model as most Spring applications do today, then there's a lot of annotation processing going on in the background. In 5.1, we spent a lot of time optimizing annotation processing performance as much as possible. Basically out-of-the-box performance, where you don't need to do much really to benefit from it, just upgrade to the latest Spring Framework 5.1x releases. In 5.2, we went a bit further based on some specific requirements. We essentially completely re-implemented our annotation processing algorithms, and we opened them up a bit. There's a more flexible version of that API now called merged annotations that allows some really sophisticated interaction with complex annotation structures of ours. You might be aware that Spring has a meta annotation model. You can compose annotations, declare meta annotations on those annotation types, and you inherit their characteristics. You can override attributes from those meta annotations. So that's a quite complex arrangement, and it's not easy to efficiently parse this. The Merged Annotations API allows callers to introspect that such a structure and to efficiently query such a structure without resolving too much. So if you're only interested in particular information, then that's the only thing we really extract. The common Spring annotation facilities all call the Merged Annotations API underneath the covers now. So there is a transparent benefit here, but it's also available for direct use for more sophisticated retrieval needs. Beyond this, and this is not actually available in M3 yet, we intend to introduce an annotation presence registry, or more importantly, an absence registry. Basically a programmatic facility allowing you to give us hints about essentially which annotation types are even potentially declared on which component types of yours, on which packages of yours. In all likelihood, you're only going to use certain annotation types in very specific packages, and there might be many annotation types that you're not using at all. So by telling us that we don't need to look for them, because we can't make that assumption, we don't know whether you're using them. But if you know that you're not using them anywhere, or not using them in a particular package, whatever, on particular hotspot annotation component types of yours, then you can tell us, give us that. We're going to respect it, and we're going to bypass any introspection efforts for that annotation type on the affected component classes. That this is a form of tuning, right? You give us hints about assumptions that you can make in your code base that we can't make in the general framework, and we're going to do our best to efficiently react to those hints. Another facility that is going to be possible around this is integration with information that comes from indexes. This is mostly a bootstrap time arrangement. You could programmatically give us some hints, but you could also get it out of some index that is being created at build time usually. Maybe it's being built by some other tool already. Maybe you're introducing a specific index as a tuning measure. So Gendex, for example, is commonly used or sometimes used with Hibernate, where basically Gendex has all the reflective information and the annotation information for a certain set of classes. If you know that such an index is available, you could evaluate it on startup and basically parse the index or get certain information about Spring-related component types out of that index and instruct our annotation presence registry with that metadata so that we know out of an index that certain annotations are never going to be available on certain component classes, as mentioned before. So this is quite in-depth optimizations. If you're optimizing for startup time, this might be quite essential. If startup time is not your primary concern, you can probably just forget about those facilities. They are mostly there as hotspot optimizations. If you find out that for certain services of yours, startup takes longer than expected, in particular if they are taken up and down all the time in cloud deployment environments, then you might want to optimize this. Otherwise, just go with the defaults and the performance, the startup performance might be good enough for your purposes anyway. Let's go a little further down that line. If you're optimizing for startup time, there's a very hot topic out there at the moment, and that is native images built with GraalVM, or more specifically with the Substrate VM subproject in Graal. GraalVM is a new Oracle effort. It's a new Oracle product with a community edition and an enterprise edition, and it recently had its first release, GraalVM 19 GA. 19 as in 2019, it's the first release, right? But next release is 20 GA in 2020 next year. So GraalVM is a long time effort, has been in development for many years at Oracle and does many things to many people. So it's also about running polyglot applications with different languages on the JVM. It's replacing the C1, C2 compiler in hotspot, or at least aiming to replace it. But for our purposes here, it comes with a native image tool. This is still in early adopter state, so it's not actually part of the standard Graal distribution. You need to do an extra installation step to get it, but it will go out of early adopter stages next year in all likelihood. So what can you do with this? You can basically take a Java-based application, like a Spring-based application, and try to build a native image, a native executable out of it for a particular platform. That native executable is very constrained. There's many things that it cannot do. It cannot do runtime class definitions. It cannot do runtime reflection about metadata that it doesn't have. So it's a very different kind of execution environment. It's not your regular hotspot JVM. Building a Spring-based application for a native image deployment target is not trivial. There's a wiki page that we have down here that summarizes the current state of the art. At the moment, there's quite a bit of extra configuration that you need for GraalVM. But actually, let's connect back to our previous topic. If you're building a Spring-based application entirely with functional facilities, with programmatic bean registration in particular, then in all likelihood, it will work on Graal as a native image out of the box without you having to configure anything. The problems come in when you start using the annotation-based component model, because there's a lot of reflection going on, and Graal out of the box doesn't know which of those annotations, which of those reflection steps are going to be necessary at runtime. So there's a configuration mechanism in the GraalVM native image tool where you're basically instructed to preserve reflection information for certain classes that are included in the native image. We are hopefully going to be able to optimize that development experience. At the moment, you basically manually configure those, and we just provide a bit of help with how to get there. Ideally, there would be a build time task that, according to Spring conventions, identifies classes out of the box in your code base that need to be processed accordingly, where we need to retain reflection configuration for the native image. So we can hopefully automate this for the typical Spring application so that you will only have to configure exceptions to the norm. This is an absolutely challenging effort. I mean, GraalVM is a great piece of technology, but it comes with so many special conventions and limitations and trade-offs that it's not a trivial technology to deal with. It dramatically improves startup time. in our prototypes, if you do this to a common Spring Boot-based application, it basically bootstraps instantly almost, right? There is no significant startup time anymore. No CPU cycles spent, at least on, not many CPU cycles spent on startup. There's a dramatic difference to bootstrapping on the hotspot JVM. It also comes with a totally different memory consumption pattern. So you might see a significant reduction in memory use, a much more predictable use of memory in comparison to a hotspot JVM. So it comes with many qualities, but it also comes with trade-offs. It is not as capable as hotspot in optimizing for peak performance, like really hot code paths that are being very called very often and identified by hotspots to be compiled as efficiently as possible according to the runtime usage pattern. GraalVM is not there yet. It's not totally clear whether they will be there. There is a trade-off here. You're basically trading a little bit of peak performance for startup performance and for lower memory consumption, and for a lot of complexity when building the native image. By the way, building a native image takes several minutes, so it's really a quite complex effort. This is not part of your development cycle. It is something you do, you test against every now and then, and it's something you do when you build the deployment unit. It literally takes several minutes even for quite small target applications. Well, there's a lot to say about this. We could spend an entire hour just talking about the implications of native images, but this is just a little bit of insight that I meant to share here. We did a lot in Spring Framework 5.1 already to avoid kind of unnecessary little glitches when you're trying to use native images. In 5.2, there's explicit instructions and a few further steps taken, summarized in that wiki page, and we expect there to be a form of out-of-the-box experience, probably with some build time task sometime next year. So, wrapping up the performance section, the implications on the component model can be very, very explicit, right? There's a lot that we can do for you to any kind of Spring applications. There's a lot of transparent tuning that you can do, where you don't have to change your components at all, to touch them at all. You can externally specify hints that allow us to more efficiently process your components. But there's also some things you can do within your component declarations, within the component model, that allow us to more efficiently process it. I mean, you could, for example, register everything through programmatic registrations. That is by far the most efficient way of doing it. But if you're doing if you're going with the annotation-based model, there's a few little things you can do. Configuration classes, if you're heavily using that feature, many configuration classes in your code base, you might want to switch to what we call the light mode to declare proxy bean methods equals false. You're basically saying nobody's ever going to call those methods externally. They are only going to be called individually by the container as a factory method for a particular bean. So if you have an add bean method calling some other add bean method and you're expecting redirection through the container, then you need bean method proxying. If all your add bean methods are totally independent, they don't call each other, then you can switch off that feature, which means we don't need to create a CGlib subclass at runtime, which saves us some effort. And saves also some meta space for those classes. So it also reduces memory by a little. And it makes it more GraalVM compatible because we can't do runtime CGlib subclass definitions in a GraalVM-based deployment unit towards a native image. The same goes for the choice of proxying. If you're using aspect-oriented facilities in Spring, you have a choice of a dynamic proxy, an interface-based proxy, and a target class proxy. The good old choice has been there for so long. The implication here is that interface-based proxies are more efficient to process, in particular for startup time, so not necessarily for invocation performance. But interface-based proxies are handled by the JVM itself. GraalVM can be instructed to understand certain proxy classes for certain interface types. There's the out-of-the-box feature for this. Whereas CGlib proxies are much more involved, creating runtime subclasses and kind of being outside of what a standard JVM usually wants you to do. So trying to optimize in particular for startup performance or for native image compatibility, you might want to choose interface-based proxies if you can. If you can touch your classes, you could introduce interfaces and switch to interface-based proxies even for an existing code base. But we're mostly talking about new code written, new microservices written, where some of those performance patterns really matter, where you can then respect those conventions from day one. All right. So much for these topics that really keep us busy. So I'm mostly sharing stuff that we are working on, that we spend most time working on. But let me wrap the storyline up with a little bit of reactive. In Spring Framework 5.2, aside from all of the stuff we've been talking about, we're also trying to complete our reactive efforts to some degree, our reactive component model efforts in particular. You might be familiar with reactive web controllers, typically run on the Spring Web Flux stack, essentially a Spring MVC controller, Spring MVC style controllers with the controller stereotype and the mapping annotations, but pretty specific signatures. So in case you haven't seen this before, look at the return type declarations. Those methods don't process a particular request. They build a reactive pipeline that is capable of delivering a response for the given request. So they're really only building a pipeline. They are totally non-blocking operations that return a reactive pipeline that is being run on a reactive kernel and efficiently processed. In the case of WebFlux, it runs on an event loop, so it's a very efficient use of threads underneath. You need to adhere to a lot of conventions, as you might be aware. You can't do blocking operations here. You really need to consistently code in the reactive programming model. There's Mono and Flux here. Those are two specific incarnations of what is being called a reactive streams publisher. Those two types come out of the Reactor project. Mono is essentially a publisher for a sophisticated publisher for a single element or none, and Flux is a sort of stream, an unbounded number of elements potentially. Both of them are reactive streams publishers and are being directly integrated into our runtime processing stack. Such methods, this method style has been introduced in Spring Framework 5.0. In the meantime, there's quite a bit of sophistication in this. So this is a reactive web controller typically run on the WebFlux stack, on Netty, so totally outside of a servlet container. And it is required to only have reactive signatures on such a stack. But there's also a little variation of this. Even on Spring MVC, on a servlet container, you can choose to use some such methods for specific operations, for specific requests. We are trying to do our best then to take these reactive pipelines that you're giving us and to run them on the servlet stack. It's a programming model, right? It's decoupled from the runtime operations to some degree. So the most efficient way of running such controllers is, of course, on the pure reactive stack, on the WebFlux stack. But even on Spring MVC, we're basically taking your mono that you're giving us and we're switching the servlet request to the async mode, and we are adapting the mono to the servlet async processing mode, async stream processing. So there's a little bit of input stream and output stream adaptation that we're doing there. There's even a bit of back pressure. We're basically taking the semantics of a reactive pipeline and trying to do our best to execute it on a servlet container as efficiently as possible there. This typically makes sense if you just need it for a few operations. If most of your operations are standard servlet style WebMVC operations, blocking operations using JPA, using Hibernate, using whatever, but there's a few operations where you would really benefit from asynchronous execution, from a bit of back pressure, maybe some specific endpoints with long-running needs, then you can choose to use some such reactive endpoints even on the Spring MVC stack. On a similar line, and this is actually 5.2 now, we are taking the reactive model to a few places where it was missing before, in particular to transactions, and this is also a connection to the follow-up talk. If you have a reactive service declaration and a reactive repository. Basically, service or repository operations that return reactive streams publishers here in a style similar to WebFlux as component classes that are typically delegated to from a WebFlux controller. Then you might want to use transactions. As of 5.2, we have a facility in place here. It's the good old edge transactional annotation. So there's no difference really in the declaration style, but it's a different mode of operation. So if we find add transactional on a method that builds a reactive streams publisher, we know that there's no point in wrapping the call of that method with a thread-bound transaction as we usually do. We go into a different mode of operation. We are essentially decorating that returned pipeline. We are adding a transactional operator to it. And that transactional operator basically manages a transaction context that flows with the pipeline. So all of the operations in that reactive pipeline are going to have access to a transaction context if they understand it, if they can make use of it. This only makes sense with certain technologies, with certain reactive data store drivers in particular. At this point, it's the R2DBC that we're going to hear about next, the R2DBC implementation in Spring Data. It's MongoDB, and very recently there's some Neo4j effort, right? So we need support for this, support for transaction semantics in a reactive data store driver. And we support it at this point in the corresponding Spring Data modules. They are implementing the new SPI that we have in the core framework for that purpose, to give you an experience that combines the declarative transaction model with add transactional and the reactive programming model for data access in particular. So there's an alternative SPI here, so you actually need an implementation of a different SPI to make that work, and they come with R2DBC, MongoDB, Neo4j is not being mentioned here quite yet. The setup and the annotations that you declare are essentially the same. Add transactional on the affected methods, add enable transaction management, and a transaction manager bean implementing that specific SPI above in your context. Two further places that we take reactive to that it hasn't quite been before. There's now a reactive messaging model, an explicit dedicated reactive messaging model in the Spring Messaging module. This is in particular motivated by our RSocket support, another topic that we could spend an hour on, so I'm just really giving the reference to you here. It's about message mapping annotations that typically operate, or like message mapping like callbacks, they typically operate in a blocking form. In this case, they don't follow the traditional conventions like in GMS, where you have a blocking invocation model. Here we have a reactive invocation model. Like WebFlux controllers, those methods build reactive pipelines that are then being integrated into the runtime stack. It's left up to the messaging stack to process them. They're run on a Reactor kernel again. So this is a brand new work in 5.2. RSocket is not quite final yet, so we're really tracking a moving target, but it's a very, very interesting technology. It's even a sort of architectural style where you would build a particular backend as an RSocket-based application, RSocket-oriented application, replacing traditional HTTP endpoints to some degree with RSocket message channels. So let's wrap it up at that point. Last but not least, there's also an effort, an literally ongoing effort, like literally today actually. It's something I've been working on the train from Krakow to here. It's the support for reactive return values and also for completable future return values from an event listener callback methods. Spring had an application event facility for so many years. But it comes with some variations, multicast modes of operation. But the application listener, the event listener implementation model is pretty traditional. So basically just a callback, you return void or you return some follow-up events to be sent. Introducing reactive capabilities here means that the event listener callback methods can declare a reactive return type. They can choose to build a pipeline. And we're trying to do our best at runtime to invoke that pipeline, to subscribe to that publisher, and to emit follow-up events as necessary in an individually asynchronous form. So instead of switching the entire multicaster to async processing, you can selectively choose for each and every event listener, each event type, how you need to process it, whether it should be in the standard code path for the caller that publishes the event, whether it should be asynchronous or deferred. All right. Underneath those covers, there's quite a bit of adaptation going on. So for the ones interested in this, whenever we say mono and flux here, we also mean RxJava types. You could, whenever you're using mono or flux, you could also use RxJava 2's flowable or single, for example. We know how to adapt them. There's a facility underneath the covers. We prefer the reactor programming model because that's what our kernel is based on. But you can also choose to use RxJava types for everything that we've been showing here. And as of 5.2, you can also choose to use Kotlin coroutines, another topic that is worth an hour. So suspending functions, brand new feature in Kotlin. We adapt it the same way, like we adapt RxJava, to our underlying facilities. Kotlin comes with a quite rich supporting API, SPI for Kotlin coroutines, coroutine context that we adapt to our reactor context. So there's some very immediate adaptation to our reactive streams processing model underneath those covers. That is quite sweet. Gives you a sort of imperative programming model in the form of coroutines, but it's actually running on a reactive stack underneath the covers. So if you ever get into Kotlin or into recent Kotlin versions, coroutines are going to come your way. All right. Well, so much for this tour through Spring Framework 5.2. There's much more in the details. We always have little refinements all across the board. But I was really just focusing on particular areas of specific importance. You could also say those are the themes that we spend most time on in the 5.2, in the 5.1 and 5.2 iterations in particular. So I hope that these things are useful to you, that there is at least some maybe transparent benefits that you get just by upgrading to 5.2, some benefits by more closely interacting with 5.2 facilities once you upgrade it, and of course then the reactive facilities that kind of complete the offering. They are mostly designed for, of course, entirely reactive applications. So if you're starting a new project, a new service, and you choose to code it on the reactive stack, then 5.2 should be your version of choice here, because it really completes the story for reactive architectures to the degree that we originally envisioned. All right. Thanks for your attention. If there are any questions to any of those topics or any topics I haven't touched upon, I'm happy to have them, but I guess we're going to go into a break. Shall I take a question while I'm still here?
I didn't catch the name of the validation process in IntelliJ that you mentioned.
Oh, it's called constant conditions and exceptions, if I memorized it correctly. It is a common inspection that is generally very helpful in kind of analyzing your code path, but it can also inspect the nullability declarations. There's also a more general one that is just says nullable, not null conflicts, but that is really declaration conflicts, semantic mismatches that don't make any sense. That is also helpful, but that's you hardly run into this. The more interesting one is the constant conditions one. Strange name, but really useful inspection.
I have a question about the situation with Jakarta EE.
Right.
I recently noticed that Spring Framework started to switch to the new APIs, so the independent switch. And I'm wondering, what is your long-term policy with that? Because as I see Spring doesn't really need any framework on compliance with Servlet or something like that. I'm wondering about if the future might be like that, that Spring Boot will run on your server made with Pivotal that doesn't implement servlet on any old technologies, but it's your code, and you might sell extensions to the Spring, so companies that want to run the Spring on Java EE or Jakarta EE servers might do that.
Right. Well, yeah, that's a complex topic, right? But to your specific points, we don't have any plans to deviate from our current arrangement, really. There's the Spring MVC stack where you can run on servlet containers, and that is traditional servlet containers, minimum servlet 3.1, so Java EE 7 or 8, and also Jakarta EE 8, which is basically a re-release of Java EE 8 in the same namespace, javax.servlet as before. We have no immediate intentions to move away from those namespaces. There are discussions in Jakarta EE to fork the namespace into Jakarta.servlet and kind of a parallel world of in a different namespace. The pragmatic people that we are, we have no intentions to even consider this until that has any traction with any particular server products. If you looking out there, there is a very common server choice for Java-based web deployment units, and that is Tomcat. It's by far the most popular, right? It's like 70% of the space almost. So that is our primary reference point and the default choice in Spring Boot. In parallel, we have the Webflux stack, so for a reactive web stack, where we typically run on Netty, where the Servlet API has no relevance at all. Where there's an internal adaptation layer that can use the Tomcat kernel or the Jetty kernel or the Undertow kernel or Netty, right? But there's no Servlet API exposed or properly involved here. We don't really have any plans beyond this. So we have our own adaptation for our own SPIs for the reactive stack, and we have the Spring MVC on servlets. We are not going to introduce anything else that is special to us. If you'd like to run on a Jakarta EE-based server at some point in the future, that server product is going to support the existing specifications like Servlet 4.0 and JPA and so forth for the foreseeable future, even if it also supports some other API variant in parallel. It will always, at least for the foreseeable future, support the Java EE 8 level of APIs. So that's our assumption that we work with. To your initial point that we moved to Jakarta artifacts, we specifically moved to the Jakarta provided EE8 artifacts because there are no further artifacts being produced by Oracle. So even maintenance artifacts for like Servlet 4.02, so maintenance artifacts for the existing specifications, the existing Java EE8 specifications are being produced by the Jakarta project. And that's what Spring Boot moved to. Spring Framework is actually still on the older facilities because we have to compile against Servlet 3.1, and so that's the arrangement. In summary, there's no change, of course. It's going to remain the same for the time being that it always was. Spring Framework 5.0 has a Java EE 7 minimum for the integrations that use those APIs. But if you look at a reactive web stack, you might not use any of those APIs anyway. There might not be a servlet API. You're not going to use JPA. Not sure whether you're going to use bean validation. So there are Spring-based applications out there that make no use of Java EE APIs at all anymore, I would argue. In a typical Spring MVC application, you might find servlet JPA bean validation in particular. JMS is basically a legacy technology at this point. We keep supporting it for those needing it, but there are really more modern messaging architectures, several variants of those all over the place. WebSocket processing is actually a really nice match with the reactive web stack, so I'm not sure that the WebSocket spec in Java EE is really going to remain relevant for all that long. So yeah, I mean, it's a very individual affair, but we've always been looking at it like Spring specifically integrates with certain Java EE APIs for certain purposes in an optional form that you choose to use. We keep holding on to that arrangement. According to your choices, there might be less and less use of Java EE APIs in Common Spring applications, but that's not really our call. I already mentioned before that we are toolbox providers, right? You choose from that toolbox what makes sense, but there's a trend in a certain direction.
Okay, so I was asking that because the Jakarta moved to the new namespace. Oracle forbids them to use Java's namespace in the new API. So
going forward.
Get you right. So Spring will work with both in the future, with Java EE and Jakarta EE namespace.
Okay, so you're specifically interested in the namespace change. That hasn't happened yet. There's a lengthy, multi-hundred message discussion on the mailing list, but nothing has actually happened yet. And there's certain consensus evolving that for Jakarta EE9 and higher, they might use a forked version of those APIs in the Jakarta namespace. But the way I handle those things is I'll consider it when I see it. A mailing list is just a mailing list. I'll basically, well, more specifically, I'll consider it, or will consider it, when somebody implements it. A repackaged API is basically no good to anyone, right? It really needs to be implemented in a specific server product in order to be usable. What those discussions on the mailing list currently suggest that future Jakarta EE-based servers would have parallel support for the Java EE8 level, the JavaX packages, and for the potentially emerging Jakarta packaged equivalents. So you would be able to deploy a servlet for row-based application to a Jakarta EE9 or 10 server. In all fairness, they need an audience, right? So they need existing applications to be deployable to their new server products. This is a necessity, it's unavoidable. In terms of the repackaged versions in new namespaces, if those were actively developed with interesting new features or API revisions coming there that really make a difference either to users or to integrators like us, we would be interested at least. I'm not seeing this for the time being. A re-release in a new namespace, I'm personally totally not interested in. Once new features emerge there and are only accessible through those new APIs, well, we'll see. But for the time being, that's just not an expectation that is going to fulfill itself within the next few years. If, say, Hibernate 6 or Hibernate 7 afterwards chooses to implement a Jakarta persistence version of JPA, we would be interested in that. We want to integrate with that. So there might be some parallel support of the JavaX version of that API and the Jakarta version, the Jakarta packaged version of that API. Maybe. We don't know yet. For us, those APIs are basically integration points. Integrating with Tomcat, with Jetty, with Undertow, integrating with Hibernate, with Eclipse Link, with Hibernate Validator. Whatever those providers choose to implement, that's what we're going to integrate with. It's as simple as that. And for the time being, they all implement the Java EE8 level in the JavaX packages. So that's what we keep integrating with for the time being. There's anything beyond that is guesswork, unfortunately. But it is an important topic, of course. Those APIs need some form of future. Right? There needs to be a path of evolution in some form. Yeah, we'll see where this goes. It's not our call. We'll basically adapt to whatever the market chooses to use, whatever the community or the market also in terms of the customer base chooses to use going forward. That's as much as I can summarize at this point.
Dobry wieczór. My name is Mark Paluch. I'm working as well with Pivotal, and I'm project lead of the Spring Data project. And this brings me quite close to the topic I'm going to talk today, which is about reactive relational database connectivity. So for me, to get an impression, who of you has already done reactive programming? Quite a few. Okay, that's nice, cool. For the other, like 60%, I want to give you a brief introduction what this is all about and what specific problem we are trying to solve. Now, to understand what reactive is, we probably need first to understand what we are doing today. Today, when we are writing the typical web application, we are writing line by line, and this style of coding is called the imperative style of programming, because we instruct the machine to do things: declare a variable, assign a value to a variable, run a database query, issue an HTTP request. And we get quite a lot of that. So first, this is the primary programming model we are used to. So we're quite familiar in how the code looks like and how it is going to be executed. Because we get that guarantee that the first statement is going to be executed and the second statement has to await until the first has completed, so we can then proceed with the outcome of the first statement. And although we do not see it immediately, we get some sort of blocking behavior in that, which means we have to await for the first line to execute before we can really process with the next line. So imperative style of programming is sort of married to the blocking nature and blocking execution. Another thing that we do not immediately see is quite often we run, our code is run on a thread by request model. What do you mean by that? So think about a web application. We have an incoming web request, and then the container assigns us a thread that is then used to execute our code. So this is the thread by request model. Now, why is this relevant? See, since a couple of years we have this ongoing trend to cut our monolithic applications into multiple parts. And we call that microservices because we start distributing a lot of small instances. And quite often we end up in a scenario where we have still dependencies between these services. So when I have an inbound request on some machine, I need to reach out to service A, B, C, and D in order to fulfill the entire request. And in very few occasions, we end up with an architecture where we can handle an entire request solely within a single process. So why is this relevant? Well, see, with this monolithic approach, we have one JVM, perhaps one machine. If we want to be highly available, we have perhaps a second machine. But the key point here is that everything that happens in a monolith stays in a monolith, and we have calls within the very same process. So we share memory, we share CPU computing power. And as opposite for that, in a microservice scenario, we encourage inter-process communication. And this is reaching out across probably the network to another remote instance. And there's a subtle difference in within process communication and inter-process communication, because for inter-process communications, we typically use the network. So we have to write out a network request. It has to be transported across the network to some remote peer site. The remote peer has to be up, has to decode that, process our request, and send all of the data, all the response back. Now, what does our application do in that time when we are encouraging a network request? Well, in the imperative style, it is blocking. And by blocking, it means that the thread that we are holding onto cannot do any useful work. Now, this relates a little bit also to the resources, because threads do not come for free. Threads have to be paid with CPU computing power and memory. And these are bounded resources. We can't have endless of them. Sure, we can go to AWS or Google Cloud and increase our capacity, but at some point, somebody is going to ask, yeah, can we do something about the bill? And this is probably not the most pleasant moment. Another thing that also plays into that with this microservice idea, where we previously had in a monolithic environment a single JVM, now we are running multiple JVMs. And you know, running a JVM does not come for free. It has also to be paid with CPU and memory. Now, this is probably a scale that not everybody of us reaches where we run out of rack space, out of computing power. and then we have to rethink. But this is more like a scale like Netflix, like Twitters, like GitHubs of this world, where folks need to reconsider, okay, we have plenty of resources, we keep these resources busy by waiting for remote requests, and we need to do something about that. And this is exactly the point where reactive programming comes into the game. Now, the key thing that reactive programming is solving, and actually that's the magic behind that, and if we dive into that, we will see that this is no magic at all, is we are using non-blocking calls. So we no longer block threads when we engage inter-process communication, but rather we describe what we want to do, and then some kernel is going to materialize these calls by using non-blocking APIs. And this does not only sound complicated, but also we will see a little bit of code. This is complicated. So you do not do reactive programming just out of fun or because you have heard it on a conference or a user group talk, but you do reactive programming because you have to, because you do not have another option. Or you have a very compelling use case that can be solved much easier and much more efficient using reactive programming than imperative style programming. Now, when we go into reactive programming, we leave one key assumption of the imperative style programming model behind, which is the threading model at all. In reactive style programming, we do not longer have this assumption on which particular thread our code is running, but rather the execution environment is assigning us these threads. And quite often, not in all cases, but in quite a few places where we engage inter-process communication, we walk down the path of concurrency and async processing. Again, reactive programming has no opinion on synchronicity, asynchronicity. It has only an opinion that everything that we transport in a reactive world has to be a non-blocking signal. It also has a key differentiator to pure asynchronous APIs. So in reactive programming, we tend to think about data as flows. So we do not handle any longer lists or collections of items, but rather we see the data as a pure stream of singular elements. I have a stream of person, a stream of orders, a stream of connection, a stream of HTTP requests, these kind of things. And to allow that kernel to efficiently work with these streams, to not overwhelm a slow consumer with a fast publisher, there's a key concept called pull, push, back pressure. So we have multiple components that talk to each other, and these components originate from the reactive streams specification, since Java has no baked-in reactive support. And the reactive streams specifications comes with 4 interfaces, but actually only 2 are of interest in that scope for us. And the 2 are, on the one hand, a publisher, and the other hand, a subscriber. A publisher is a definition of what you want to do. This can be a web request, this can be a database query, this can be a definition, send my message to a Kafka broker, these kind of things. And on the other hand, you have the subscriber. Now, a publisher, as I said, is a recipe, and it does not do anything unless a subscriber comes around and starts subscribing to that publisher. So the subscriber sends a subscribe signal to the publisher, and only then the publisher starts doing its work, opening a connection, writing network data out, waiting for that data, but in a non-blocking way. And as soon as we get inbound data, a response, the publisher starts emitting data. Now, the subscribe and data signals are true signals, true events. So they are non-blocking calls, and the publisher makes sure to send the right data to the right subscriber, because they have manifested a link, which is a subscription through the subscribe signal. Now, with this non-blocking nature, it is possible to basically produce more data than the subscriber can consume. And the net effect of that would be an out-of-memory error exception. And this is something we probably want to avoid. So at this point comes this back pressure idea into play. The subscriber is able to tell its publisher how many data elements it is able to process at a time. So it is requesting 1 element, 10 elements, 100 elements, depending on basically the capabilities and the capacity of your system. So we are requesting basically a number of elements from the publisher. And the publisher is so smart enough that it produces only up to these n elements which are requested by the subscriber itself. And it guarantees to not produce more elements than that. So this is the idea of back pressure. Let's take a look at a little bit of simple reactive code. Well, simple perhaps in codes. So what this bit of code is doing is reaching out to two services and getting their health check and returning a composite health element. Now, if you are not familiar with reactive style programming, this might look like gibberish to you in the first place, but rest assured, after a couple of months of learning, this will be somewhat readable to you. And this is one of the characteristics of reactive style programming, that you have to have this knowledge how to express your code, how to run it, and how to debug it from the very first day. And the learning curve for reactive programming is quite steep. Now, what do we do here? We are working in a Spring scenario. We have a controller method that is using Spring's web client. This is the functional web client. And what it basically tells is, I want to have a GET request to the alpha service, to the health endpoint, and marshal, please, the result as health object. We do the same for the Bravo service. And then we formulate, please zip these things together, which means basically, as soon as both responses are coming in, then we want to take this tuple of data and do something with that. So this is the map step. And if you are familiar with Java 8 streams, then map is basically what Java 8 streams map does for you. Now, what makes reactive programming so efficient? So let's play through that with the three known scenarios that at least I know: imperative, async, and reactive. So the pattern is clear. So we want to reach out to two services and then marshal the results together and give them back to our caller. In an imperative style execution, we would fetch the data from the first service. Our thread would wait until the response comes back. Then we would reach out to the second service. Same there, we have to await the response. And then once both responses are available, we can marshal them together and return a composite health object. What have we achieved then on the resource side? Well, we have used a single thread. We have blocked it for a fair amount of time, at least as long as both requests take together, so in sum. And then we basically we can read that code. This is one of these advantages. We know how it behaves. But we weren't quite efficient. So we have used a fair amount of resources and we have waited for quite a long time. Now, if we go over to async, we would probably deal with completable futures. And assuming that our web requests run on a thread pool, we would kick off the first request, the second one. We would not block when we call these methods to obtain the future. But what we would have probably to do is synchronize and await. So we trigger off the first request, it goes to the first server. We trigger the second one, and the second one goes to the second server. And afterwards, we get to futures. We synchronize them together to obtain and await the result. And then we can progress on with that. What have we achieved on the resource side? Well, we have used 3 threads, but we have improved on the latency side because both requests run now in parallel. So this is a little bit of an improvement for a bit win for the latency, but somehow a loss for resources. And really, depending on how the client is implemented, I get then very different characteristics for the execution itself. We could probably optimize this to 2 threads if we would chain the completable futures, but again, this is something we could dive very deeply into that. Now, if we do this in a reactive way, we have a single thread that subscribes to the first publisher. It starts creating a connection, writing out the request. And it's not waiting for the request, and the thread is not blocked in the first place. Then the thread goes to the second publisher, subscribes there, does basically the same. And then the thread sees, okay, there's no more work to do here. Then it goes to somewhere else to perform some work. And as soon as both responses come back, a thread is activated, runs then the map method, and returns the result. And the net effect of that is both requests run in parallel, so we have optimized for latency, and we have used a fraction of a thread time just only for writing all these requests, parsing the response, doing the mapping. And this is where the power of reactive programming lies in. And when we are talking about reactive systems, we talk probably about thousands, 10,000s, 100,000s of concurrent requests on regular hardware. So this is the scale where we are talking about. Now, if we go this endeavor into reactive programming, we have to be reactive everywhere. See, if we drop blocking components in a reactive system, we immediately lose all the benefits of reactive programming, and we have a pretty high chance that we start blocking the small number of threads that are available in the reactive system, and so that we kill with a single blocking component our entire application. So this is probably not something that we want. So therefore we need to be reactive everywhere, and all of our integrations have to be reactive as well. So this means our web clients have to be reactive. Our messaging systems have to be reactive. Luckily, the web client is reactive, at least the Spring one. We have integrations for things like reactive Kafka or RabbitMQ. But, you know, events aren't the only way how to communicate data, how to communicate state. A fair amount of our applications is still persistent state bound, which means we store data in databases. And good news, at least for the NoSQL folks, there are reactive drivers for MongoDB, for Redis, Apache Cassandra, and Couchbase. But this probably is also just a small fraction of all users, because in reality, the data persistence is dominated by a SQL database. And you know what? The only way how to access from Java SQL databases is JDBC, and JDBC is blocking. Now, when we, I think it was 2 years ago, presented Spring Framework 5 with our reactive story, the very first question was, what about JDBC? What about JPA? Can we use that? And through a quite long time, we had the only answer, which was, no, we can't use it because it is blocking. Yes, you can put it on a thread rule, but this is a bad idea. Why? We will see that later on. Now, at some point in time, we didn't want to come up with this no answer, but rather find something which enables users to use SQL databases in a reactive programming endeavor. And so we started investigating what we could do. And after a conference like 2 years ago, we came up with the idea, let's investigate how an reactive API could look like for databases and how drivers could look like. And so we eventually came up with R2DBC, Reactive Relational Database Connectivity, a specification created from the ground up to embrace reactive patterns and reactive behaviors. So RTBC is a specification for database drivers and also a specification that clients can adopt on and to provide client functionality on top of that. What do you need for RTDBC to use that? Well, you need Java 8 because the majority of us is still coding against Java 8 APIs. And we need something which is reactive, and the obvious choice here is reactive streams because Java 8 has no reactive stream support baked in yet in Java 8. So these are the two dependencies that you need in order to use and consume RTDBC. And if you look on this dependency arrangement from Java 9 perspective, we will see that with Java 9, reactive streams was incubated into the JDK itself. So if we would move the baseline up a version to Java 9 plus, we could use the Flow API and RTDBC would be basically dependency free. Now we have made our own, made up our minds and set ourselves a few goals. What about the design principles and the idea where we want to go and how this API should look like? How should a modern database SPI look like if we want to engage into reactive programming? Now, one thing is entirely clear: we have to be reactive everywhere. Otherwise, it wouldn't have no point to come up with some reactive API, right? So every time we start a conversation with a database, which is creating a connection, logging in, running a statement, every time we need to be reactive and we have to use non-blocking APIs. And this is why we are using in these areas and these method calls publishers. We also want to embrace the reactive properties that are brought us by our relational databases. And to be honest, relational databases are the best fit for reactive programming because, you know, they have logs and asset properties. But this is probably something we can live with. But they also have cool features like cursors. And, you know, we have this backpressure idea where we know how many data items a subscriber is interested in. So we can translate that backpressure into things like a fetch size from a cursor to load only as many data as is required by the client itself. We also didn't want to just drop a bunch of Java files and that's it, so we're done, but rather to specify exactly how RTDBC has to behave, what a driver vendor has to implement, what he has to provide in order to claim to be a RTDBC compliant driver, and what a client author can expect from RTDBC is coding against the RTDBC SPI. And talking about SPI, this is a service provider interface. And this is intended for the communication between the database and the client author. This isn't necessarily intended for end application developer use. But we will walk anyways through the code so you get an impression what RTDBC really means. And this idea of shrinking the SPI to a minimum comes from the fact how JDBC is currently built. See, JDBC is great because it enabled us since like 20 years to access and integrate with SQL databases. But JDBC isn't a pure driver API. It is both. It is a driver API and it is an application developer API where we as developers should be able to code against JDBC directly. Now, it turns out that only a small fraction of us is using JDBC directly. Most of us are consuming JDBC through some sort of client. Hibernate, Spring, MyBartis, JDBI, eBean, these kind of things. And we wanted to come up with a modern SPI and wanted to leave this client part to where it really belongs, to client developers, and only abstract that part away which differs from database to database. And these are typically the protocol-specific things. Now, with JDBC, as I mentioned, we have things like WJUG, MyBartis, and so on and so on. And this is also the goal for RTDBC to enable client authors to code against an interchangeable driver SPI. So to say, to give them a common language, a common understanding, so they can build their clients on top of some reactive SPI, so they can then provide meaningful features for us, application developers, so we can consume directly then the client on a higher abstraction level. One example for this user space features in JDBC is this abstraction over parameter bind markers. So every time we use prepared statements and we want to fill in parameters, we have to mark them with this question mark. And what a driver has to do is parse the SQL statement and replace all these question marks with vendor-specific parameter bind markers. And we explicitly decided we do not want to do that. We want to leave this aspect up to the client because, you know, in some cases, database portability matters, and in some cases it doesn't. And it does not make sense to provide a feature to everybody without really knowing whether it's required or not. Now, let's go through the RTDBC SPI, and we will see like 5 classes, which are interesting for us. So it all starts with a connection factor. And perhaps based on the name, you might imagine this is a factory for connection, which makes it quite obvious. So the connection factory is the entry point to your driver, and you obtain a connection from a connection factory. If you are familiar with JDBC and the data source, you know probably that you want to obtain a connection from a data source itself rather than from the driver manager every time, because you do things like pooling, or you have a routing component which routes certain database calls to one data source and other calls to another data source. And this is also an idea we picked up on that end. So a connection factory can be a driver, but it can be also a connection pool. It can be a proxy for connections. It can be a routing component. And so you could decorate an existing connection factory to augment it with additional features and functionality. Now, once we call that create method, we get a handle to the publisher. And once we subscribe to that publisher, we get eventually a connection created. So the driver is starting then the connection handshake. Okay, the connection handshake, doing the login, and once the database connection is ready, we can then finally use it. Okay. Now, let's take a look on the connection itself. The connection has a ton of methods, really, and it has basically the methods that are necessary to deal with the primary idea of SQL database, which are transactions itself. So we can begin transactions, we can commit these, we can interact with the isolation level. These are things which are necessary, but not necessarily things that we want to deal within our application. But remember, this is a SPI intended for client authors in the first place. From a user perspective, or from an application perspective, what we really want to do is running statements or running batches. And batches are a collection of statements, so let's take a look into a statement. We create a statement by handing in a SQL string, right? And then we get a statement object back. And we have only a single statement interface because we find it is not necessary to carry out the fact what type of statement it is. And if we take a detailed look into JDBC drivers, we will sometimes see that prepared statements aren't prepared statements at all, but it is rather what we call a parameterized statement. But you know, even that fact isn't really so important that we need to encode that as a own type, but rather if we have an unparameterized statement, select asterisk from foo, then we just call the execute method. We do not bother ourselves with any parameter bindings. We just execute it right away. If we have a parameterized statement that declares parameter bind markers, we would start calling these bind methods or bind null methods to provide parameters to the actual statement and then run it. And good news here, we start counting at 0 with this indexing, so no longer +1 and counting, which is a good thing, I think. Now, once we have provided all the parameters to our statement, we execute it and we get a publisher of result. And so this means we start again a database conversation to run that statement or run it multiple times, depending on how we have set up our statement. And then we get one to many results. And the result can be consumed today in two ways. One way is to obtain the number of affected rows, which is interesting for insert, update, delete statements. And the other way is consuming the tabular data that we get. And to consume tabular data, we have that map method that accepts a function, a mapping by function, and that by function gets as input parameter the actual row and the row metadata. And again, row metadata is something that an automated client is interested in. If I would call that as a human user, I would probably know the SQL statement, and I would know which columns are part of that SQL statement, so I would be probably interested only within a row. Now, this mapping by function is applied to every single row which streams into the driver. So as soon as we receive a frame with a row in it, we decode that particular row. and then we stream out immediately that result which was mapped. So therefore we get there also a publisher of T, and T is defined by the outcome of the mapping by function. And a row can be consumed only in a single way with a get method. You pass in either the column name or the column index, and optionally you can provide it a type hint. How would that look like now in our code? And don't be scared, it will be more code over time. Now, it all begins with a connection factory, and to make proper use of publishers and not spam the entire slides with publisher chaining. This is probably the thing that we would need to do if we wouldn't have a composition library like Project Reactor and RxJava. So for this examples, I choose to use Project Reactor as composition library, which brings me then methods like flatmap many, these kind of things. So it all begins with a connection factory where we create a connection. Once the connection is ready, I'm intending to run a statement, which is select value from test. I'm executing that, and this is creating me another publisher. As soon as results stream in, or the first result streams in, then I can specify the mapping method to extract the value column out of this result. And this mapping function is applied to every single row, which is received by the driver itself. And so I get a publisher of object, because the get method itself has an object return type, because it does not know about the type. And we didn't want also to pollute the API with like 20 methods, which are all typed to something different. So our result type would be a publisher of object, and the publisher of object would return every value from every row that is received as the query. If we want to beautify this to some extent, we can specify the type hint. So to say, get me that value as string, and this type information is propagated all the way down. And now we have a publisher of string, which is a little bit more convenient. Now, let's go to modifying statements. They are basically created the very same way. I create a connection, create a statement, provide my statement SQL in there, which is insert into test values and a few parameter bind markers. And if we look at that SQL statement, we will see that there is $1, $2, and these are Postgres-specific parameter bind markers. We can't make Postgres counting from 0. We can't do that, we can't force them, but at least we have an index notation, and we can use this $1 and $2 parameter bind markers when we issue the binding. And that's exactly what we're doing here. We're binding the value 100 to 1, and the value 200 to 2. But this is not all what we are intending to do here for this example. What we actually want to achieve is we want to run this statement twice. Once with parameters 100 and 200, and the second time with 300 and 400. And if you pay close attention, after the second bind, there is this add method. And what this basically does is, it is telling the statement, I'm finished with binding my first parameter set. Please start over with the next binding set, so I can execute that statement multiple times with multiple binding values. And since the driver knows best how to execute these kind of statements, with the execute method, the driver engages the execution. And this can be either used by using prepared statements and running that statement twice, so compiling the statement first, and then running it once with parameters 100 and 200, and then running it for the second time with 300 or 400. Or Postgres, it can use a single message, a single round trip to the database by saying, this is my SQL, this is my table of parameters, now go. And since the driver knows best, we really want to hide these specific aspects of that execution. Cool, so we have seen selects, we have seen inserts, but what we haven't seen yet is transactions. And to engage into transactions, we have to do a little bit more. And this is the aspect which starts making the code really ugly. So for transactions, we have to begin the transaction first before we even do anything of our work. Then we apply our work. This could be a single statement. These could be multiple statements which are executed and chained to each other. In any case, after applying all of our work, we have to clean up the transaction by either committing it, if everything was successful, or rolling it back. And in this example, every time an exception is raised, the transaction is rolled back, and we have to propagate that error. And this is starting to make this thing ugly. And even one more thing is missing. See, we are creating a connection, but we are not closing it anywhere. So adding that, again, would even make more of this reactive code here. So my slide would be probably too small for that to show it all. Now, this is all nevertheless great, because now we have something that works with reactive patterns, which is non-blocking, but it is way too verbose. See, this pattern that I showed you with try catch, finally try catch, to begin a transaction, commit it and roll it back and propagate that error. This is the right type of pattern that we want to engage. Patterns stay very much the same between imperative, async, and reactive programming, just the way how we express that differ these programming models. So the conclusion here is we need a humane API so that we as application developers can code against it. And based on this motivation, we came up with that idea to provide an RTBC client. So that's how we called it. An RTBC client is more of an experiment and evaluation inspired by JDBI than a real production-ready client. And it is by no means a reference implementation. It is just to show how a reactive RTBC client, well, 2 times reactive, how a RTBC client could look like. Now, we create that RTBC object, again with a connection factory, and then we have this RTBC object that we can then work with. And what we basically want to express is, within the scope of a connection, I want to do some work. And this is exactly what this code is doing. We are calling this withHandle method, which is resource management. So it opens a connection, applies then our function to that, and afterwards it closes the connection. And we express in a very slick way, listen, I want to run a select query. I hand in you a select a SQL string, and then afterwards I apply a mapping function to a row, because I know the SQL string and I know which values are coming out of that. So I'm interested probably in this case only in the value column, specifying also the output type, which is string, and then I end up with a flux of values. Why flux? Well, RTBC itself depends only on reactive streams, but the RTBC client needs some composition library, and using Project Reactor was a natural choice. So RTBC client uses Project Reactor, and Flux is one of these return types provided by Project Reactor. If we want to engage into modifying activity, like an insert, we need to specify, again, SQL. We can't work around that, probably. We use, in this example, the very same withHandle method to also express we want to apply this activity within the scope of a connection. We can bind values to that statement and then just execute it. And by executing an update statement, we typically do not have tabular data, but rather what we have is that update rows count, so how many rows were updated. And this is exactly what the execute method is returning us. So therefore, we end up with a flux of updated rows. Now, let's go over into transactions. And yes, this is the transaction slide. You probably haven't noticed. So let me go one slide back. Pay attention to this withHandle method. This is without transactions. This is with transactions. So what basically changes here is I'm calling just a different method, which gives me different semantics. So I not only get that connection management, but I also get transaction management, and just by calling a different method, and then I'm able to run multiple statements within an atomic transaction. And I think this is how a client should look like and how it should feel and look like, instead of going directly onto the bare metal RTBC SPI. Now, RTBC client was driven by RTBC itself, and we from a Spring Data side were also quite excited into looking on RTBC and experimented a bit how a client could look like for functional reactive database access. And we eventually came up with the idea to provide, to mirror what we have for the web part. For the web part, we have this web client, which allows us in a functional way to express how we want to interact with HTTP resources, right? And for databases, we have the database client. We created with a connection factory, and then you can express in a fluent way how you want to access your data. And one of the entry points to the database client is the execute method. It accepts a SQL string or a supplier of SQL. Then you, if the statement is parameterized, you can bind values to that. Afterwards, express how you want to consume your data, either as a flux of map that maps the string column name to some object, or map it to a domain object, like here with a person. And afterwards, you can tell the Spring Data about the multiplicity. Do you want to consume all your rows? Do you want to consume just the first one, or exactly once? And this is how we envision a functional reactive database access. We also care about database statement portability. So if you pay attention to the SQL string, then you will see in the last part, where name equals double column name, that this is a named parameter. And this is something which is provided by Spring Data itself. So database client is dialect aware, and it does this transcoding of the SQL string for you, because we care about database portability, because we care about productivity to support you with what you probably want to achieve. So the driver no longer does this, but the client is implementing this particular feature. And based on the metadata information that we use in other Spring Data projects like MongoDB or Cassandra, we are able to leverage that mapping functionality. So every column which comes as a result set value is mapped then to the according value within my person object. And this either by convention or by using things like column annotations or table annotations if you want to persist that entity then back. But really, the database client is just the infrastructure layer, if we want to will so. What we probably really want to do is working with reactive repositories, with RTBC repositories. So database client builds the infrastructure for the repository layer. So if you're already used to imperative style repositories, then instead of deriving from CRUD repository, you extend from a reactive CRUD repository. By doing so, you get a handful of methods already provided as an implementation, like save, find by ID, find all, count, these kind of things. And if you want to specify your own custom queries, you are free to do so. You just write the method signature, put an @query annotation on top of that. You are able to leverage named parameter bindings, and then you just call that interface method. And this is how reactive database access in general should look like. Query derivation is not yet implemented, but it will come in a future release. Now, Juergen already told us there is an upcoming feature in Spring Framework 5.2, which is reactive transaction support. And reactive transactions are very different from imperative transactions. See, when we go back to that imperative style programming model, we have this implicit assumption that all code runs on the same thread. So imperative transactions work with thread locals to store their transactional state and to augment your functionality. And every time we need to interact with the transactional state, we use thread locals. Now with reactive programming, we no longer have this binding to a particular thread. So we cannot longer use thread locals because thread switches happen at arbitrary times. What we can use instead is something called like the reactor context. And this is in particular a feature from Project Reactor where we can bind contextual data to a flow, to a particular execution. And this is how reactive transactions are built in Spring Framework. And to basically rephrase what Juergen said, the only thing that you need to do is change return types if you want to engage into reactive transactions and reuse the very same transactional annotation, and the transaction interceptor will see that we are returning a publisher type and then augment the entire flow with a transactional operator and run this transaction in a reactive way. You can also use a programmatic way by using the transactional operator. So if you want to go in a programmatic way with imperative transactions, you would use the transaction template, and the transactional operator is basically the reactive variant of that. And we can use that in the very same fluent way how we express also our reactive pipelines. So we chain things together. The first call is a save call to save a person. The second one is saving an address. And then we express that we want to do all this within the scope of a transaction. So we say transactional as transactional operator.transactional. And then all these upstream operators are participating in a transaction. And if the first succeeds, but the second fails, then the entire transaction is rolled back, as you would expect that from a transaction management system. RTBC has even more to provide. Perhaps you remember JDBC connection URLs. This is a cool tool for configuration frameworks. Not so much for driver implementers and users, because every single time you're switching a driver, you have to switch to a different URL scheme, and every driver has also to implement that parsing functionality. We thought, let's do that better and standardize the connection URL for RTDBC and implement connection URL parsing directly into RTDBC instead of letting every driver vendor implement their own parsing. So we have standardized that URL. It looks and feels like a real URL. We know there is an RTDBC scheme. We know the second segment is always the driver. We know where to put the host name and port name. The path part is translated to the database name. And we have a scheme how to provide vendor-specific extensions by just using query parameters. And you are handing in this URL to RTDBC and getting a connection factory in return. What you also can do is things like delegation. So quite often you engage a connection pool. For testing, you probably use an in-memory database without connection pooling, but for production, you would use connection pooling. And we inspect the connection URL itself and looking for the segments after RTDBC and before the host part. So here in the upper example, we have RTDBC column pool, column Postgres. And what happens here is that we go to the pooling component first, and then the pooling component configures the connection factory for you. And this without even touching your own code, just by specifying the connection URL. Now, what can we do with RTDBC today? Well, we are on the road towards a GA release. Since this is actually the most asked question, when can we have it? And we aim for the end of the year, somewhat. It started like 2 years ago with just an experiment, and now we have a couple of drivers available for SQL Server, for Postgres, 2 community drivers for MySQL, an H2 driver for in-memory testing. They all are capable of batching, handling transactions. They have an extensive type system. They have support for large objects to not exhaust your memory if you load like a 2 gig payload from your database server. They are leveraging partially database-specific features like cursor and fetch sizes. We have a service loader-based discovery mechanism, so you drop just your driver onto your class path, and the discovery mechanism is able to configure your driver without you having to specify anything further than just the connection URL itself. And we also are at the state where we have an ecosystem. So this is probably something we never have dreamt of, but now we have the specification document itself. We have the SPI as an artifact. We have the RTBC proxy. I will tell you in a minute about that. We have a connection pooling component, so you can really use that without a penalty of creating for every operation a new connection. We have the community who started adopting RTDBC with MySQL, with Google Cloud Spanner drivers, and the community is continuing to pick up on RTDBC itself. We have various client implementations. The Spring Data one is actively under development. We have the RTDBC client, WJUG, JUOQ, is picking up on RTDBC support, and there is a Kotlin one which I cannot really pronounce, so I won't try. Now, what is this RTDBC proxy? So you have heard about things like Micrometer, Zipkin, App Dynamics, New Relic, these kind of things, which are able to pull out information from your runtime system. And they do it for a lot of Java components, and one of these is also JDBC. But JDBC has the thing that it does not provide a standardized metrics API, where you can hook into connection creation, where you can hook into statement execution. Some drivers provide interceptors, but others require these vendors to rewrite bytecode on the fly. And in both cases, these are not the things that you really strive for doing, but you have to do that in order to provide metrics for your system. So we were asked to provide some answer to give insight into a running RTDBC system. And like 2 or 3 months after we got that initial ticket, somebody from San Francisco showed up, which isn't affiliated at all with us, and showed us, look, this is RTDBC proxy. And what RTDBC proxy is it wraps a connection factory, and it allows you to register callback hooks. And these callback hooks are called every time a connection gets created, a statement is started, a statement is finished. It notifies you how long it took to process and receive a particular row. So we can pull out of RTDBC proxy and its mechanism to augment connection factories a lot of data that we can then push into Micrometer, Zipkin, Open Tracing, Prometheus, or if you're an APM vendor, then you can build on top of RTDBC proxy. So this is our way how we want to provide observability features for RTDBC itself. Now, we should also talk now a little bit of what RTDBC really gives us. This all sounds sort of fancy, but RTDBC solves only a single issue, and this is getting rid of the thread congestion by providing a non-blocking way to communicate with your database. Not more, not less. We have still to stick to the rules of the protocols of the database vendors. We cannot just go to them and entirely turn the world upside down, because we are just a small fraction of users. However, because we solve that threading problem, we can engage RTDBC in reactive applications. We do not solve, however, this problem of locking. So if we have 2 concurrent transactions, we have still to wait until the first one is committed before we get responses on the second connection. So this moves really the locking and congestion problem back into the database again. And this is something really to consider, because you can easily overwhelm your database. And this is again something why I am convinced that SQL databases aren't the best fit for every reactive scenario. So you have to be really careful about that, because connections are, from a JVM perspective, cheap. From a database perspective, they are really expensive. Now, there are a couple of alternatives. Initially, I said, yeah, let's put JDBC on a thread pool. And it turns out, for demo cases, it works, because if you put something on a different thread, then your call looks like as if it would be non-blocking. Yes, this is true. But you know, threads are bounded resources, and so we cannot have too many of them. So we need to spin up a thread pool. Typically, in a reactive system, we have as many threads running as we have CPU cores, and every additional thread causes overhead. But if we are willing to pay that price, let's make this thought experiment. Now, I have this thread pool where I offload my blocking JDBC work. I cannot do anything about that JDBC is blocking. I cannot magically turn it into something non-blocking. I can put the problem just somewhere else. And this somewhere else is my thread pool. And if I have 10 threads, and I have a reactive system which is quite busy, like with thousands or 10,000s of concurrent requests, you could imagine that this thread pool gets busy and exhausted in a very short amount of time. What do we do with request number 11 and 12? Well, typically we put this into some sort of queue. And Java provides us with two types of queues, unbounded ones and blocking bounded ones. Now, unbounded queues, as the name says, accept runnables, because that's how they are, how work is represented on the thread pool, except these runnables in an unbounded way. The only limit that you have there is the physical memory in your box. So what happens at that end is that the queue fills up rapidly, and eventually you run into an out-of-memory error because you have queued so much work because you have only 10 threads and they are still blocking, and ending up with an out-of-memory exception is probably not the best idea. So we rather should switch to blocking bounded queue. And if we bound that with, say, 500 requests, then we are able to buffer a number of requests before we stop accepting requests. But you know, this blocking queue, if you use it in a blocking way, starts to block if you go beyond that limit. So we end up again there where we started. So JDBC on the thread pool is not the best idea if you want to run it in production. There are, however, other alternatives like vendor-specific APIs in some drivers. There are some Scala drivers, there are some Java drivers which can integrate with Postgres, with MySQL. But however, come always with a vendor-specific API, and you cannot put a client on top of all of these, because you would need for each and every driver an adapter layer. This is one thing. Another thing is Oracle announced like 3 years ago ADBA, which stands for Asynchronous Database Access. 2 years ago, they have shown a little bit of code, and since then, this is actually it. So we have a little bit of code in a Mercurial repository, and we have no real implementation. We have no releases of ADBA so far. We shouldn't copy Oracle code because this ends badly. So the only thing we can do there is just wait, sit and wait, or talk with these people and wait. But in any case, we do not get any release so far. The only working implementation of ADBA is ADBA over JDBC. We had that topic about JDBC already. So ADBA isn't really an alternative for us. In any case, we have to progress from our side to provide at least something to enable you developers to integrate with SQL databases when you are engaging reactive programming. And at some point, we need to collaborate and consolidate the ecosystem, because nobody wants to have 14 or 15 or 16 competing standards. So this is something which we will need to do in the future. Right now, everything that I told you is already available. We have milestone releases available. The current milestone state is 08M8. And now I'm switching to the things that the future holds for us. So our goal, ultimate goal, is to provide you with a GA release somewhat towards the end of the year. And we probably will see some additions over time to RTBC. And this is the reason why we do not say it is 1.0 GA, but rather 0.8 GA, because we cannot guarantee fully backwards compatibility across our evolution. We initially thought nobody is using stored procedures, but there are obviously still people who are using stored procedures, so we have to support that at some point in time. We also realized, based on the efforts with connection pooling, with reactive transactions, that we still need to extend the SPI. And these are things that will flow into the SPI at some point in time. We will also see releases of additional drivers, like for Google Cloud Spanner. DB2 and SAP HANA folks are investigating on drivers, and eventually they will come up with drivers, or they won't. So we do not control them, so this is something that the future really will tell us. And eventually we will also give the driver development back to the driver vendors. We, as Pivotal, have started on driver development to prove that the concept is working. With the H2 driver, with the Postgres driver, with the SQL Server driver. But we aren't the folks who typically maintain drivers, so we would love to see the vendors stepping into that development so we can share our development with them. And what we also will eventually see is support for additional clients, for MyBatis, for JDBI, probably for Hibernate Reactive. They are also investigating on RTBC itself. That being said, we get close to the end. So RTBC is an open source endeavor. All the code is Apache version 2 license. It is available from GitHub itself. So if you go to github/RTBC, you will find the RTBC organization and all the code, all the implementations, all the contributions that we have there. We have also a website that explains in depth the capabilities of the individual drivers, if you're interested in that. And it holds also all the resources, all the links to the Java doc, to the specification documents. You can reach out to us via GitHub or via the mailing list. And at this point, I really encourage you to give RTBC a try if this is something which matters to you and to your project. You shouldn't bet your entire life on RTBC yet, because still we are like 2 years old with this project, and we have to prove that RTBC is something that survives also production. But you can use it in your test projects, in your spikes or non-critical applications as soon as it is GA. And before GA, play with it, see how it behaves for you, for your use case. And if you are missing certain features, reach out to us via the mailing list. Only when we know that there are missing features or features which are badly implemented, these things happen, only then we can react to that and make these things to be a better place or add your particular feature. And if you are really deep in RTBC development, we have also a monthly call on every first Friday. So we discuss there the current progress of RTBC itself. That being said, do you have questions now?
Can you explain a bit more what happened? You explained that we can easily overwhelm the database, the connections. Typically, databases have, for example, 50 connections to a single server. And what actually happened with R2DBC? How this propagates? For example, Spring Server clients connects to the server, execute statements, and what happens in that case?
Okay, so these are actually two things. So an RTBC driver itself opens connections as fast as it can because it is non-blocking, and by doing that in an unbounded fashion, you can basically kill your entire server. Perhaps you could kill even your entire data center with a single machine, because this is the power of reactive and non-blocking. So you need to limit that in some sense. And the thing that you typically would do is using a connection pool, where you specify the maximum number of connections that you want to allow. And there you would put some sensible number of connections in there. But this is not the end of the story, because what do you do with additional requests that come in? With the current pool implementation, you can set a limit of how many additional requests you want to buffer. And if you are reaching this, then the pool currently rejects additional connections. Perhaps they will also add in a future version to wait a certain time, because this is something that Commons Pool or DBCP are currently using. Just waiting until some connection becomes available. But these are features to be added perhaps in a future version. Does this answer your question?
Yes.
Okay, cool. Any last question?